In this video, I'm going to discuss definite integrals. Now, a definite integral has a start and an end value. In other words, you'll be given an interval from two specific limits. Now, there's a difference between a definite integral and indefinite integral. Now, if you look at these two graphs, this will help you to visualize the difference between a definite integral and an indefinite integral. Now, on the left, you can clearly see that the indefinite integral has no specific limits. Okay, you don't have the lower limit and the upper limit. It's just the integral of f of x with respect to x. And in fact, when we looked at indefinite integrals and when we started discussing the integration, we realized that the indefinite integral actually gives us a family of functions. Okay, but a definite integral has specific limits. In this case, the limits are from a to b. Now, a definite integral, as we'll later see, it gives you a numerical value. So you can actually work out the specific value of that integral. I'll show you that later on. Now, there's some notation that you need to be familiar with at this stage. The first thing is if you want to write a definite integral, of course, it will have the upper limit and the lower limit. In this case, the lower limit is a, the upper limit is b. So you have this expression on the left can be read as the integral from x is equals to a to x is equals to b of f of x with respect to x. We'll do lots of this when we start solving questions. Now, what I also want to discuss before I start working out questions is the process of finding the definite integral. And this is carried out in 4 steps. So the first step is, so step 1 is finding an indefinite integral. Finding an indefinite integral. Say, for example, f of x. This is our indefinite integral. Step 2 will be you write your result in this form. So you write your result using limits. So we'll use this kind of brackets, f of x, and say the limits are from a to b. Step 3 will be you substitute a and b into f of x. So you substitute a and b into f of x. And the final step will be you subtract the value that you obtained from the lower limit to the value that you obtained from the upper limit. So basically, you'll end up with something like f of b minus f of a. And basically, this will be a numerical value. Okay, very important. This will be a numerical value. I mentioned that before. So how do we write this? All this information, how do we write it in as a single statement? So we write this as the integral from x is equals to a, from x is equals to b of f of x with respect to x will be equal to, use this kind of brackets, f of x, and this is from A to B, which will be equal to f b minus f of A. Now, important things. This is called the upper limit. This is called the lower limit. Okay. Here what you're doing is you evaluate at upper limit, and here what you're doing is you're evaluating at lower limit. So the difference between those will be a numerical value, and that's what you're looking for. That will be the value of a definite integral. So we've discussed a lot of things. Let's try and now apply this in solving a question. Okay, so the first step, of course, is to integrate. So this will be equal to x to power 3 over 3 plus 4x squared over 2 plus 2x. The limits are from 0 to 1, which will be equal to. Now, let me just simplify this before I actually substitute this value. This is 2x squared plus 2x 1 0. That's better. Now, find the difference of these two. So I'll end up with 1 over 3 plus 2 plus 2 minus the second bracket will just be 0. So minus 0, because 0, if you plug in into all this, will just be 0. So my final answer will be 13 over 3. That's it. As you can see, our final answer is a numerical value. Okay, it's not a family of functions, it's a numerical value. Next question. Now here I'm going to explain a few things. But first of all, as you know, this is one of those questions that you have to integrate using substitution, by substituting. So let u to be equal to 1 minus 2x, which means that du over dx will be equal to negative 2. So dx will be du over negative 2. Now, remember, this integral has limits, but once we substitute u into this integral, those limits are for the value, these original limits are for the values of x. But once we substitute u, we are going to end up with an integral with respect to u. So which means that we have to change the limits. What I mean here is, since we have a new variable of integration, it means we need to have new limits. So new variable of integration means new limits. Okay, so we need new limits because our new variable of integration will be u. So to do that, we can actually use this substitution here to work out the new limits. So we'll say at x is equals to negative 1, u will be equal to 1 minus 2 to multiply by negative 1, which will be 3. And then at x is equals to 0, Remember, those are the original limits. So at x is equals to 0, u will be 1 minus 2 multiplied by 0, which will be 1. Which means my new integral here will become the integral. And now at x is equals to negative 1, u is 3. At x is equals to 0, u is 1. Okay? So 3 over u multiplied by dx, but dx is du over negative 2. So what I'll end up with is negative 3 over 2 integral of 1 over u du, which will be negative 3 over 2 ln absolute value of u. Don't forget to put in the limits. And then we substitute in the limits. So negative 3 over 2 ln 1, okay, minus negative 3 over 2 ln 3. Right, let's finish this off. So what you'll end up with is ln 1 is just 0. So we'll end up with 0 minus into bracket negative 3 over 2 ln 3, which will just be 3 over 2 ln 3. Our final answer will be equal to 3 over 2 ln 3, because absolute value of 3 is just 3. We can also use our graphing calculator to work out values of definite integrals. So I'll show you how to go about this process. Okay, so suppose you're given a question like this. The first thing is to plug this expression in your calculator. So alpha window, go to number 4. The lower limit is x is equals to 2. The upper limit x is equals to 8. Plug in the integrand, which is x minus is the fraction here, 3 over square root of x, and we are integrating with respect to x, and your final answer will be 21.5. So final answer will be 21.5. To work out number 3, I'll use two methods. One is the algebraic process by integrating using substitution and simplifying my final answer. The other one is using the calculator. So method 1, which is just using substitution. Now this question is very similar, I think, to number 2. So let u be equal to 1 minus 2x. du over dx will be negative 2, which means that dx is du over negative 2. At x is equals to negative 1, u will be 3. At x is equals to 0, u will be 1, which means my new integral will become 3, 1 over u multiplied by dx, which is du over negative 2. So that means I'll end up with negative a half 3, 1 over u du, which will be equal to negative a half ln u, absolute value of u, 1, 3. Okay, now we need to plug in 1 and 3, so that will be negative a half ln 1. Now ln absolute 1 is just same as ln 1, so ln 1 minus ln 3, which will be negative a half into 0 minus ln 3, which will give us a half ln 3. So that is the algebraic process of working this out. You can also use your calculator to work this out. Now, to use your calculator, all that you need to do is plug in this function, integrand, or the integral. So just clear that. So alpha window, let's go to number 4 again, negative 1, 0, 1 over, oops, I need a calculator here, so I need a fraction here. So 1 over 1 minus 2x, x there, just checking that everything is okay, and then you'll end up with that answer. And if you check what I have here, the answer that I had initially, it should be the same. You can always check, which is I have ln 3, and you end up with the same answers. So you can use this method, or you can use your calculator. You should be able to end up with the same answer. Now, this is an interesting question. You'll know why later on. Anyway, let's just follow the same process of how to integrate it. In fact, this is very similar to this question. So all that I'll do in this question is let me use the same processes. So method 1, I'll use the algebraic process. So let u be equal to 1 minus 2x. du over dx will be negative 2. So dx will be du over negative 2. At x is equals to negative e, okay, u will be 1 plus 2e. Just substitute negative e into that. At x is equals to e, u will be 1 minus 2e. Substitute in place of x. So which means that our integral will become, the lower limit is 1 plus 2e. The upper limit is 1 minus 2e. 1 over u multiplied by du over negative 2, which will be negative a half integral 1 plus 2e, 1 minus 2e. 1 over u du, which will be equal to negative a half ln u, very similar to what we had initially, only that we have different limits, 1 minus 2e and 1 plus 2e. Now, what we'll end up with here is, if we plug this in, so we'll end up with negative a half ln 1 minus 2e, absolute value of 1 minus 2e, minus ln absolute value of 1 plus 2e. I'm going to try and apply some laws of logarithms here to simplify this question. So that will be negative a half ln 1 minus 2e divided by 1 plus 2e. You know, I'm just using this law of logarithm. If you have ln a minus ln b is equals to ln of a over b. If you remember that, just laws of logarithms. Okay? Okay. So I end up with that as my final answer. Well, but let's try and check using our calculator if this answer makes sense. Okay? So if you use your calculator to plug in the whole equation, so same process from the lower limit in the original question. Okay, the lower limit is negative e. The upper limit is e. Our integrand is 1 over 1 minus 2x. And we are integrating with respect to x. Now, if we press enter, what happens? Let's wait and see. Okay, it's taking time. Oh, there's an error. Divide by 0. Anyway, to investigate this error, what we can do is let's try and graph this integrand. Okay, I'm going to graph this integrand in my calculator to see if it's a continuous function between negative e and e. Remember, it has to be continuous for us to be able to integrate it. If it's not continuous, then we won't end up with any solution. In fact, if it's not continuous, then this answer will just be useless. Okay? Anyway, so if I go back to my so here's the function 1 over 1 minus 2x. If I graph it, it looks like that. Now you can see that this function is not continuous between e and negative e. Okay, it has a vertical asymptote. In fact, its vertical asymptote is a half. So, which means this function is not continuous, which means you cannot integrate it between these two limits. So, what you're saying here is very important. So, this answer here, okay, it's just useless. Anyway, so the best word to use. But what I mean by that is if the integrand is not continuous, in the interval of integration, it is not possible to obtain a numerical answer. It's not possible to obtain a numerical answer.